Our first speaker today is going to present on development of EPDM/NR-based UV-resistant non-black rubber products for outdoor applications. The presenters are HKKP Athapattu, NMVK Liyanage, and N Narangoda. Please welcome Ms. Athapattu.
Good afternoon, everybody. Welcome to the presentation of development of EPDM NR-based UV-resistant non-black rubber products for outdoor application. This research study is supervised by Dr. Liyanage and Mr. Narangoda. First, we move to the background of this research study. So, a variety of rubber products are used in outdoor applications where UV resistance is needed. Especially when consider about the natural rubber-based product, when exposed to long hours to the direct sunlight, it faced with major problem is color fading and the discoloration. And it had been noted these problems are caused due to ultraviolet radiation. So, accordingly, my research objective is to develop a UV-resistant colored product compound to be used in outdoor applications. In here, mainly, I selected to develop the yellow color road humper, which is already used in the transport sector for further study. So, this study mainly focused on these following aspects. First, the polymer identification and the compound designing to resist the degradation of the rubber vulcanized when exposed to the sunlight, and as the second, the select product which the road humper to possess the required resistance to UV radiation and with enhancing its service life and the aesthetic properties and also the technological properties, and while maintaining competitive product price. Then when we move to the experimental part of this study, as the first, the experimental compounds were established based on natural rubber and the EPDM based rubber. So in here, can you see that the table 1 and table 2 shows you the formulations which developed EPDM based compound and the natural rubber based compound respectively. Mainly in here, the UV resistance was improved by incorporating the UV reflecting mineral fillers and also the non-staining antioxidants. Then, at the second part, the evaluation of the UV stability upon the effect of the pigments, especially according to the literature survey, the inorganic pigments has a very good UV stability than the organic pigments, but the organic pigments give the more excellent color fastness than the inorganic one. So, to observe these effects, the four samples were prepared. Especially the natural rubber based compound with only the organic pigment, and the second, the natural rubber based compound with the inorganic pigment. As a third, the natural rubber based compound with combination of the inorganic and the organic pigment. As the fourth, EPDM rubber compound with only the organic pigment. As the third part of the experimental is the selection of the curing system. So, my main idea is to develop the EPDM NR based vulcanizate. So, the EPDM rubber should want the sulfur curing system. So, the undermentioned curing system, which is already illustrated in the table 4 and table 5, were used into EPDM based compound to study the required compatibility and also the adherence with natural rubber compound, and also for getting the optimum technological properties in the composite. And already the table 4 and table 5 show the materials which are used in the special sulfur curing system and also the traditional sulfur curing system. As the final part of the experiment to develop the vulcanizate compound with actually two-layered compound with the EPDM based rubber and the natural rubber based compound. So then we move to the results and discussions. So already you can see these figures shows the color variations of the effect of the pigment, especially with the effect of the pigment, and already you can see the sample 1 shows the bottom is the dark color when exposed to the weathering, and the other samples are only cover to the bottom layer, and these are the top is the exposed to the sunlight. So in here mainly you can see the more discolorations in the discolorations was appears in mainly the natural rubber based compound with all pigments with inorganic and the organic, and also combination of both organic and inorganic. But already I have mentioned before that the inorganic pigment has more UV stability than the organic one, but it wasn't enhanced the UV stability in the natural rubber based compound. So can you see the EPDM based compounds with organic pigments, it wasn't appeared any significant discoloration with the organic pigment. So next, the curing characteristic. This table shows the rheological properties. Especially, can you see the yellow color bar that the high torque value, MH value, it shows the very low value for the EPDM based compound with the traditional sulfur curing system than others. So it clearly indicates that the EPDM rubber based EPDM compound specially needs the special sulfur curing. So actually this result is leads me to my next point, that if we want to get the EPDM based compound with the natural rubber based compound, so the EPDM needs the special sulfur curing system to get the very good compatibility and also adherence with the natural rubber based compound, and also for getting the optimum technological properties. Actually this is the results of physical properties. Especially can you see the elongation and break, tensile strength. In here sample 5, 6, 7, 8. In this sample 5 is the EPDM with traditional sulfur curing. It gets the very low value because of the low cross linking, and the sample 6 the pure EPDM based compound with the special sulfur curing system, and the pure sample 7 is the pure natural rubber based compound with the normal sulfur curing system, and sample 8 is the 2-layered compound with the vulcanized compound. So next move the other physical properties, the tear strength, hardness, abrasion loss. So when we go through all these physical properties, already we can clearly see that the developed vulcanized compound will also get the well-balanced physical properties when comparing other pure EPDM based compound and also the pure natural rubber based compound. So, so by considering all these factors, already we developed that 2-layered compound with as the top layer of the EPDM based compound, with giving the very good UV resistance and the very good aesthetic properties. And here the bottom layer of the compound, natural rubber compound, is only the it's give the cheaper products, and the durability and the cheaper products. So by considering all these factors, we developed the product which road humper, which is already used in the transport sector. It's give very good UV resistance and also the very good aesthetic properties and very good optimum technological physical properties. So and the cost evaluation of the reveals also that the product is financially feasible. Actually, I think that is the end of my presentations, and thank you very much for your kind attention. Thank you.
Any questions? Let me comment on that. yeah.
Okay.
I was going to say that. Yeah, Prashant.
Yeah. First of all, I didn't follow which institute you are attached to.
I am UOFSI Inculcating. That's the Industry and University Collaboration. University of Morocco and collaboration with the industry.
Okay. Okay. The second question, you said pigments molecules based on inorganic and organic, pigments. So, I mean, what are these molecular structures?
Inorganic pigments, it's iron oxide.
Okay.
The organic pigments, monomer group, that azotite, that yellow color pigments, that chromophore transaturation bonds give the actually that organic monomer group azotite.
Okay.
Can I have a question from that corner, please? I'm hell-bent on getting at least one. Yeah, that corner. Anyone? What about this corner?
What is the cost per square meter for this?
Actually, it's 2 square meters. This product want 8 kilogram. 8 kilogram to produce this product.
Yeah.
So the whole cost maybe around 2,000, 2,500.
Okay.
So have you worked on other pigments, like now what you have showed is a yellow pigment?
Yes.
What about the other pigments, other colors?
Actually, my study mainly I select the yellow color rod humper, especially the yellow especially I studied the yellow color pigments. That's the main thing because the product want the yellow color and the rod humper, the black and the yellow. That's why I selected that product and go through that only the yellow color.
Yes. Now the shelf life or the testing, how long you have tested this by exposing for UV?
UV already 3 months. Sometimes I say.
Another suggestion now, if you can make it luminous, it is really worth, during the night time sometimes we don't see these road humps.
Yes, really.
You can give it a try.
Yes.
We of course see, I think it's something to do with
Any other questions, please?
My question is, now you said actually this is being implemented already for this product. And now, before you introduce this to the market, was it imported into the country or?
It's imported. So nowadays they imported. So
You have done an import substitution.
yes.
I think I picked up a few words from your presentation, and I have to eat my own words before I say what I said. I think this is one of the first presentations that I've seen where I've seen a few very important words. You said technical and financial viability. So before you even started, developing the product, you've gone through and done a technical and financial feasibility to see whether it's viable in a commercial sense, right? And also you, at the end of the talk, you said cost evaluation, right? So these are some of the the key ingredients of applied research, where you just don't go and blindly do a piece of work and then it costs 10 times the product that you already have. And to answer, I think, your question, I think what they've done is they've done a import substitute that costs less. So that is and using locally available materials, natural rubber. So that is a very good piece of work, I think. And if there is no questions, yeah.
Actually, sir,
Accelerate.
first, we had done the laboratory samples with
Yes.
the tensile cases. Then we prepare the product, commercial product samples, and we put in the road, especially that industry, and that is the product. Accelerated, that is the normal weathering process, and the laboratory samples we accelerated, that the UV lamps and the rubbing.
There's high flux of UV in this test.
3 months enough? I don't see.
Yeah, I mean, if you're doing accelerated testing, probably 10,000 times the UV that you get from the natural light. 3 months is more than sufficient. If you under those drastic conditions, if you don't see any yellowing, then most likely that the product will last for probably 10 years if it doesn't break down. Okay, thank you very much.
Thank you.